Hi, welcome to Dr. Raz, the Baking Chemist. So today's question is a requested question. It's a physical chemistry year 1 question, all about dilution equations. In this walkthrough, I will tell you about when dilution equations work, why do they work, and how do they work. Okay, let's see what we can do. Okay, so the question is, sodium hydroxide is often sold as a concentrated solution containing 12 molar sodium hydroxide. Calculate the volume. So they want us to calculate the volume of water that should be added to 10 centimeters cubed of a 12 molar solution of sodium hydroxide to make so they want to make a 0.25 molar solution. And it says show you're working. So whenever they say show you're working, you know there's going to be marks involved in that as well, yeah? So, you know, it's 2 marks, so I'm assuming one of those marks is for the working, okay? Now, it's all very well doing all of this on the calculator and just jotting down the answer, but then you'll only get 1 mark, okay? So just be aware of that. Okay, so let's do this now. First, let me go through this question using this dilution equation, and then I'll show you why this dilution equation works, okay? So let's do this, right? So the dilution equation, for those people who don't know, is simply C1 V1 equals C2 V2. Now, all that 1s and 2s means is 1s you can say initial, so initial concentration times by initial volume is equal to final concentration by final volume. That's all these 1s and 2s mean. Nothing special, nothing extraordinary out of those, yeah? Okay, so all you do is you think, okay, in this question, what are the initial concentration and the initial volume, and what are the final concentration and the final volume? Okay, right, so calculate the volume of water that should be added to, so they're adding water to what? They already got this volume, okay, so there's your volume, and initial concentration is there's your concentration, all right, and then they're saying solution of sodium hydroxide to make 0.25 molar, so this is your C2. So there's your C2. Initial volume is that one. Initial concentration is that one. All right. So in other words, they want us to find out the V2, that one. So you can do, you can rearrange this first, or what you can do is you can actually put the values in first, but I like rearranging first. Okay, so we're going to rearrange for that. Not difficult. Okay, so I'm just going to do it this way. So it's C1 V1 over C2, and that should give you V2. So final volume. Be careful, I'll say something about that V2 in a minute. Okay, so now let's just put the values in. All right, so it's a simple matter of C1 is your, so it's 12.0 times by V1 is your 10 divided by, and C2, which is 0.25, and calculator 480. So that means, so this is your 480 what? Centimeters cubed, okay? Okay, I'll say something about this units in a second as well later on. All right, so that's 480 centimeters cubed. But remember I said to you, I'll say something about V2. Well, V2 is a final volume. So that means the final volume is 480 centimeters cubed if you want 0.25 molar sodium hydroxide. So that means they're already starting with 10 centimeters cubed. What you then got to add is just 470. Okay, so remember, so you don't say, oh, I want to add 480 centimeters cubed. No, that's the final volume. Okay, they've already got 10, so therefore, volume to add is equal to 480 minus 10. Remember, they said show you're working, yeah? Minus 10, which equals 470 centimeters cubed. So you've got to add 470 centimeters cubed to the 10 centimeters cubed to give you 0.25 molar. Okay. Well, look, 1 mark is for that working out and 1 mark for the answer, okay? Now, so that's a simple answer, 2 marks. Yeah, it should take you less than 2 minutes if you know this dilution equation. Let me tell you why, as I said to you. I'll explain to you why this dilution equation works, yeah? Now, the reason why this dilution equation works, and of course, I'm assuming you're a chemist watching this chemistry video, but even if you're not, something to learn. If you want to find out the moles, given the concentration of the volume, what's the formula? it's N equals CV. Yeah, V could be in decimeters cubed, but if it's not, if it's in centimeters cubed, then you've got to divide it by 1,000, right? But let's assume for the time being, yeah, that the V is in decimeters cubed. Okay, so N equals CV. Now, when you're diluting this, whatever solution this is, you're not changing the number of moles. Yeah, the number of moles, the amount of stuff, remains the same before as it is afterwards. Yeah, so the amount of stuff there. So let's say if I use, so the amount of particles, let's say 4 particles. Okay, I'm not changing the number of particles when I'm diluting the solution, right? I am keeping the number of particles the same. So if I want to keep this number of particles the same, i.e. the moles, that means if I change the concentration, if I increase the concentration, I have to reduce the volume. Because remember, I'm trying to keep these moles a constant. So if that means if I increase the concentration, I have to reduce the volume to give me the same number of moles. Same thing, if I increase the volume, I have to reduce the concentration. So when you're diluting, you're not changing the number of moles, you're changing either the concentration or the volume. In other words, the number of moles remain constant before as they are afterwards. Okay, so if the number of moles before, let's label it 1, is equal to N1, which equals C1 V1, and the number of moles afterwards remain constant, so in other words, N2 equals C2 V2, and we know that the number of moles is the same, so N1 equals N2, therefore C1 V1 must equal to C2 V2. So this dilution equation works because you're not changing moles, you're changing either concentration or the volume, and that's why if you just remember that dilution equation, it will work. And of course you probably come across it in biology as well. Okay, so this is the background. Now you don't really need to know the background to be able to use this dilution equation, but I think it's worth being aware of it. Okay, and especially I think one of the questions was asked by my subscribers as well, that, oh, could you explain, you know, why dilution works, equation works. Okay, so that's that. Now some teachers, okay, and I'm probably going to be provocative in this statement, but some teachers say, oh, do you know when you're using the C1 V1, yeah, and you know the dilution equation, make sure the concentration, yeah, is in moles per decimeters cubed. You've got to make sure it's moles per decimeters cubed. Well, that's not quite right, okay? Because think about it. When you have an equation like this, C1 V1, so I'm going to say C1 V1 equals C2 V2. Okay? Let's say, you know, they sometimes say the concentration, make sure the concentration is moles per decimeters cubed, or volume is, you know, decimeters cubed. No, yeah, I think it's not correct, yeah? Why? As long as the units are the same on both sides, it doesn't matter. Let's say if volume was in liters, no, not liters, let's say it was in centimeters cubed. Well, as long as the volume in both sides is centimeters cubed, it's not a problem, yeah, because they'll cancel out, okay? Same thing with concentration. Let's say if the concentration was in grams per decimeters cubed. Well, and times by decimeters cubed volume, which equals grams per decimeters cubed on this side times by decimeters cubed. Well, as long as the units are the same on both sides, they'll either cancel each other out. So it's not going to be a problem. So if it's decimeters cubed on this side, decimeters cubed on this side, it'll cancel each other out. Yeah, if it was centimeters cubed on this side and centimeters cubed on this side, it'll cancel each other out. If this was grams per centimeters cubed on this side and grams per centimeters cubed on this side, it'll cancel each other out. The only thing you need to be aware of is what is the question asking you. Is the question asking you, calculate the volume of water? They've not said whether they want the volume of water in decimeters cubed or centimeters cubed or deciliters or whatever. Yeah, so in this case, I couldn't care less what the units of volume are, as long as I'm putting in the correct units. Yeah, so for example here, if you think about it, initial volume, they've given you centimeters cubed. So when I am working out V2, the final volume, I've got to remember that that volume will be in centimeters cubed. And that's why when I did all of that calculation, all of that, my units were centimeters cubed. yeah, because my initial volume was centimeters cubed. So that's the only thing you need to remember, yeah, that whatever units you're using, your answer will be in those units. Can you see, yeah? If the question had said, oh, calculate the volume of water in decimeters cubed, then what I do is, I still do the calculation the same way, but I need to remember that my answer is in centimeters cubed, and then I would have had to change that, convert that to decimeters cubed. So that's the only thing you need to remember. But otherwise, you don't really have to worry about the units as long as both sides, the units are the same. That's the only thing you need to worry about. So grams per decimeters cubed, yes, if the question had asked, oh, find the concentration of grams per decimeters cubed, not a problem, yeah. Final concentration grams per decimeters cubed, initial concentration, I just had to use grams per decimeters cubed. Yeah, in order to get my final concentration in grams per decimeters cubed. Okay, if they had given me the concentration in moles per decimeters cubed and they said, oh, find grams per decimeters cubed, I could have done it either two ways. I could have said, okay, well, I could have changed that moles to grams per decimeters cubed and put that value in this equation, or I could have used this concentration in this equation, and then my answer would have been moles per decimeters cubed, and then I would have changed that to grams. There's lots of different ways you can use this. Yeah, so just be aware, okay, that the units have to be the same on both sides. Okay, there are other ways of doing it. You could have worked out moles in the first, you could have done this, you could have found out moles initially in here, how many moles are there, okay, and then you could have put that moles into the second, in the final moles, so that moles you could have put it in the final equation, and then find out, concentration, of course, they've given you in the final, and then you could have found out the volume. Yeah, so that was sort of two-step, yeah, but that's the longer way. That's a longer way of doing it. Okay. I hope that's clear. I mean, just out of interest, when this exam question came up in the exam, students, if they couldn't do the first part, I mean, they couldn't remember the dilution equation. So what they ended up doing, they ended up just leaving it. But the point is, the first mark was for working out, yeah, the volume needed, the total volume needed, yeah. But the second mark was for the volume being added. So even if you had said, volume to add is, let's say you came up with 1,000, just out of thin air, yeah, 1,000 centimeters cubed, yeah, minus 10. If you had said that, 1,000 minus 10, even though the number 1,000 is wrong, but the fact that you said 1,000 minus 10, that would have got you a second mark. Okay, so think about these questions. Don't just sort of go over them and not attempt it at all. Okay, so I hope you found that useful. If you do need to know a particular question, or if you're not sure about something, please leave a comment below, or if there's another way of doing it. I told you about 2 or 3, but if there's another way of doing it, let me know. I mean, I did say to you, when do you use it? Well, whenever there's dilutions happening, yeah. So whenever you're diluting one thing to another, yeah, you use the dilution equation. Okay, how do you use it? I've explained it. Okay, using the equation. When do you use it, and why does it work? So I've explained the 3 different aspects. Okay, but if you do have anything else that you want to know, or any other question, of course, yeah, please let me know. Okay, I'll see you next Wednesday.